Hello, everyone. My name is Jason Davis, and I run product management for Backtrace IO, a Unity verified solution partner. In today's session, I'm going to be talking to you about what we've learned from game programmers that we've spoken to across the industry, about the tools and processes and methods that they love to use throughout the game development lifecycle, from production all the way to post-launch. As I said, my name is Jason. I run product management over at Backtrace IO. We have been a Unity verified solution partner for over a year now. We help game development studios provide a more stable experience for their users by providing best-in-class crash and error reporting for their games and real-time 3D solutions. This talk here is based on dozens of interviews that we've had with customers in the gaming industry over the last 2+ years. We've spoken with game programmers, technical directors, producers, QA team members, and so on, across game studios that range from AAA, really complex games for games for consoles and PC, down to casual games for mobile and web, to games in between, the AA, quote unquote, AA games that are very popular and provide great experiences. So the talk today is really based on information we've heard from you and about what tools and processes you love to use. Before we get into the talk, a little background on Backtrace and our perspective. We provide crash and error reporting for video games, 3D real-time technologies, and other industries as well. Crash and error reporting is all about capturing the non-fatal errors as well as the crashes and hangs that impact your players. We do this across all major platforms, so not only mobile, but also PC, game consoles like PlayStation and Xbox and Nintendo Switch, across the web, as well as streaming services like Google Stadia. That's what makes Backtrace kind of unique in the industry. Many of you might have seen similar tools from mobile vendors, from tools like Crashlytics, now Firebase, or from Hockey App, now part of Microsoft App Center. Backtrace is really focused on providing this for non-mobile as well as mobile games. Not only do we provide crash and error reporting, but we integrate with your build pipelines. Outside of the gaming world, we talk a lot about CI/CD. In the gaming world, it's a lot of general build pipelines, asset generation, building things for different platforms, and so on. But Backtrace integrates there as well to capture things like build failures, unit test failures, and if you start to implement things like automation and capturing errors from build pipeline tools such as Clang Analyzer and other static code analysis tools, Backtrace can really integrate and help you solve those errors as well. And then finally, really what makes us different from other tools, even something like Unity's Cloud Diagnostics, is the purpose-built database that we've designed from the ground up that was meant for high cardinality data, means errors and crashes with lots of key value pairs, so that you could really slice and dice and understand instability in your application. Enough about Backtrace. Let's talk a bit about other tools and processes that game developers love. So over the course of this talk here, we'll start off first with a brief intro to the game development lifecycle. Many of you have probably operated in this environment today. You see the flow from production to launch. Let's just break that down and have a common understanding of the game development lifecycle. Then we'll talk about the different dimensions that impact the tooling that different teams use. By dimensions, we mean things like game form factor. Is it console or mobile? Is it a multiplayer game or a single player game? Those are different types of factors that drive people to choose different tools and processes throughout their development lifecycle. Then we'll spend the bulk of the time really discussing different classes of tools that are used and specific vendors and tools as well, just as they've been brought up and some of the reasons that we've heard that people are using these different vendors and the reasons that they're using these specific classes of tools. We'll break it down to follow kind of the game development lifecycle so you can see where they start to become used. And we invite your feedback as well, right? We'll wrap up by just summarizing kind of what we've seen and hope to hear from you to see if you see the same or if in your world things are different. So let's start with the game development lifecycle. From the Unity perspective, we hear it spoken about from create to operate and monetize. These phases aren't written in stone. I've seen various different phases, but for the purposes of this talk here, we'll look at these 5 phases. First, pre-production. What type of tools and processes do people use when they're ideating about their game, when they're thinking about, is this going to be engaging, when they want to test the idea with some people and see, is this fun to play? So a lot of prototyping and game design happens during this phase. Second phase, production. This is where the most amount of time is spent. You're building your game, you're generating assets, you're creating the gameplay, and you're collaborating with your team members. Once you're done with production, there's often a structured testing phase. I see a lot of people moving testing into production as well, but we often have a beta phase where it gets exposed to users. You make tweaks and changes before you decide that you're ready to publish and launch your game. We've skipped launch here because launch is essentially an event. And for the process, for the scope of processes and tooling, we want to focus on pre-launch and post-launch. During pre-launch, we're looking at hardening. We hear people talking about identifying quarter cases, locking down their builds so that there's no new features, only bug fixes, etc. And then after launch, post-launch, we need to track usage, understand engagement and user retention, and often you need to monetize your game. There are a number of different factors that I've seen and we've seen as we've spoken to these dozens of customers in the space. And I'll focus on a few here. First, the form factor that your game is developed for really does impact what tools and processes you use. If you're building games for consoles and PC, you're usually more focused on performance and optimization later on in the game development lifecycle, especially if you have high quality assets and lots of different artistic renderings and so on. If you're focused on mobile and web, you're often focused on engagement with users. And often these games are free to play or there's a lot of in-app purchase. So you need to concern yourself some more with analytics and long-time retention of users and so on. Multiplayer needs really do drive different tools and processes. If your game is multiplayer, you need back-end servers. In fact, you might need platforms instead of just plain servers that you can easily build your game on so that it can scale out, so that it can provide matchmaking capabilities, real-time worlds where users can navigate and so on. The team size also impacts the tooling that's needed. If you have a small team, structured, error tracking may not be as important to you, but the larger your team gets, the more defined there are phases, the more processes there are, and the more structure and definition that you need around the game development lifecycle. And then finally, game complexity really does drive the different types of tools that are needed. Where you have complex artists that are drawing and creating new characters that are consuming memory and impacting your frame rate, that's going to drive a different types of tool that's needed than a 2D games that has less impact on the video and the graphic drawing capabilities and so on. So this is basically to say there's no one size fits all, but rather these are the different dimensions that drive people to choose and think about different tools across the phases of the game development lifecycle. So let's get into some of those tools and phases. I've got 5 slides, as you can see here, to walk through these phases, talk about the classes or categories of tools, and then some of the criteria that I heard and the dimensions that we heard that impacted the different choices. So first, pre-production and production. You're getting the idea for your game, you're prototyping, testing it out, and then you're really starting to build it. So you need a set of tools to help you build your game. Editors and a gaming engine is often used between Unity and Unreal. They own 80 to 90% of the market. There are a few other third-party game engines as well as proprietary engines that we see people using. The choices here, it depends on the type of game. As most of you are familiar with, Unity has been known historically for providing great support for mobile games. So if you're building a mobile game, Unity is often one of the first choices for you. Unreal historically has had a little more of a complex gaming and artistry and more photorealism and so on. So historically, folks have looked at Unreal or custom game engines, typically in languages like C++, to get the level of control that they need, to get the level of performance that they need for some of those higher performance games. Those also drive the need for different editors. Sometimes you can rely on the gaming editor, such as the Unity, the Unreal editor, but oftentimes people need to use a real software IDE. So Visual Studio, IntelliJ, are two common tools that we hear being used. As you're building your game, we think about the team size. If you have a small team, the choice around requirements management and team collaboration tools is going to be a little less focused for you. Jira is very common to be used. It's easy to pick up. There's free versions of it. They're very flexible with on-prem versus in the cloud. These are some of the reasons that we've heard Jira used versus something like Handsoft from Perforce. Handsoft has a little bit more of a gaming specific tilt towards it for collecting feature requirements and building out your stories and kind of really scoping out your game. But that said, a lot of the common software tools that we've seen, not only in gaming, but other industries, Asana, Trello, Confluence, Fogbugs, Fabricator, there's a number of these issue tracking tools or kind of board management tools, if you will, that people do use for requirements management. And what we've seen is that team size really does dictate. The larger the team, the more structured these tools need to be, where they have more defined fields that are required, maybe some more information around handoffs between different teams and so on, versus smaller teams where not those kind of complexities aren't needed. The team communication tools are very useful. We see it throughout the production phase for engineers just to collaborate with one another on gameplay, on errors, on just general feedback. Internal tools like Slack and now Microsoft Teams are seen more often. And then external tools such as Discord are just very easy to stand up and engage with not only your internal developers, but your external community as well. And later on, we'll see how that external communication feeds back in as we get to kind of the post-production phase. Finally, the other kind of class of tools that people think about during this phase, version control tools. Where are we going to store our source codes and our assets? Git, very common as a distributed, decentralized version control system that is open source and freely available and understood. Perforce is another example of a version control tool that was developed and has a different view than Git. Instead of being decentralized, it's a little bit more focused on centralization and controlling things like large assets, large visual video gameplay or video or background files or artist files and so on. Subversion is still popular. We've seen it across a number of different studios, and Plastic SCM, another kind of popular version control system in the gaming space and in other spaces, and now part of the Unity family. Version control is, again, super important because that's where your game actually lives, and you need to be, the dimensions that I've seen being discussed here are depends on kind of how heavy your game is focused on like large assets and how well the performance of the source control, the version control system is for you for things like large assets or large amounts of files, how performant it is as you're performing your build pipelines and so on. So we'll often see people, experiment if they find the performance slow on the tool that they're used to see if another tool is going to be useful for them. But often this is just something that's baked into kind of a DNA of a team of users. Which source version control tool have they used before that they're comfortable with? Some other tools that we often see during this phase, as we just talked about, source control and version control is super important because that's where your game lives. But you need build tools in order to generate the game itself. So Jenkins is very frequently used, Circle CI, Unity has a cloud build tool, Microsoft Azure is another cloud build kind of tool. GitHub now has GitHub Actions, which can be used as a build tool. I've seen that used outside of the gaming industry a little bit more, so that might feed its way in. But from the folks we've spoken to, a lot of these tools are what's common. Again, this seems to be a personal choice from kind of the beginnings of the game. Most folks are familiar with Jenkins or Circle CI. I'm gonna make use of that. if they're a newer studio and they're looking to Unity, for example, to get a lot of their tooling, Unity Cloud Build is a nice simple way to get your build done without having to procure hardware and kind of treat it as a service. So depending on the complexity of the build, it's going to drive the needs of the studio in different directions. Now, when I'm building, I've got these pipelines that are generating different build types, and this also is factored based on kind of the complexity of the game. For folks that are building AAA and console-based games, we'll often see three types of builds that are generated every time they do a build. They'll have a debug build that allows them to get a rich amount of debug information, but it has a performance impact when it's run. That's super useful though when they're running their profile or retail build and they don't get enough information and they really need to drill in and see more debug details. So the point here is to just state that we see different studios building different types throughout their build pipeline depending on the need so that they can triage their errors a little bit more or understand what the performance is going to look like in the retail setting. We don't see too much CI in the gaming space. I get the sense that's because the build pipelines themselves take a fair amount of time. So what I've seen more frequently is scheduled builds, 2 or 3 times a day at scheduled times that builds will kick off so that they can maintain a constant stream of working builds. As builds are generated, we'll see things like tools that are used in the build process to check to see how complete it is. So this is where things like map checkers, address sanitizers, other build pipeline tooling that's suggested by folks like game console vendors, such as static analysis tools that should be run. All of these can be done throughout the build pipeline so that you can generate not only a build that's playable, but also make sure that you're testing things as it's getting built and capturing errors as early as possible. And that's what some of these map checkers and address sanitizers help you do. We see a lot of people building custom tooling now. They need to file tickets very quickly with a lot of common information across them. So a lot of custom tools for scripting, for filing tickets, for auto-filling in fields, and so on. Finally, during the production phase, if you are a multiplayer game, if you're going to be an online game, you really need to focus in on which multiplayer services you're going to use during this time because you're building your game at this point. Unity Multiplayer is a fantastic service for this. We see folks also using Amazon GameLift, Azure for Gaming, PlayFab. All of these systems provide you the ability to scale up and out as your players increase in number and you have more load on those servers. They often provide things like leaderboards and matchmaking services and other things that are required for the multiplayer experience. Not only the multiplayer experience for kind of the back-end running tools, but I listed Vivox here as an audio tool. And there's a few other kind of plugins that can be used for real-time communication between players in the games. And that's also something that gets considered when you're thinking about multiplayer games. So all of this is what often happens way early in the game cycle as I'm thinking about, again, the feasibility of the game and really starting to go through production. Right? Once I've moved through production and I start to get ready to test this more structured in a more structured way, a new set of class of tools start to become thought of. So crash and error reporting, the tooling that Backtrace provides often shows up around this time when I'm getting into the testing world. And the reason that crash and error reporting typically shows up now is this is when I start really engaging with playtesting and I'm really trying to get more feedback. So Backtrace, Cloud Diagnostics from Unity, Firebase from Google, which is part of the Crashlytics evolution, and Microsoft App Center are some common platforms that are used here. Each one has a little bit of a different perspective and point of view. Backtrace comes from a native crash reporting background, so things like game consoles, multiplayer servers, and mobile is kind of built into our DNA. And part of the core technology there. Now, performance and profiling tools I often see discussed for the studios that are building for console and PC. It's often actually discussed in from the perspective of optimizing for a specific console first, and then looking to optimize for PC and other platforms. This usually does not occur during production phase. This is usually one of those structured things that does happen after we've moved out of production and into a real testing phase. The focus for performance and profiling we'll often see again on these console games and a little bit less on the mobile games. Although there are some tools there, a lot of what we heard from studios when they talked about the tools that are most important to them, performance and profiling was more important for those complex console PC-based games. So every engine essentially has a set of profilers that are built in. You can enable them to get some profiling information. This typically has an impact on runtime, so it's not run, during real gameplay, but just during testing phases. We've seen a lot of custom tooling that was developed to just capture metric information. What are the statistics for the CPU, the GPU, and the frame rate and the memory utilization at any given point in time? And then we saw specific tools used for frame analysis. So things like RenderDoc, which are an open source tool that allows you to do analysis of an individual frame, is pretty useful, again, for console-based games. One of the other tools or I'd say processes that tools, the combination tools and processes that I heard that was pretty cool was dynamic resolution scaling. Again, for complex games with a lot of visual representation and so on, dynamic resolution scaling allows studios to define a target frame rate and adjust the resolution so that you can meet that frame rate. So that allows you to have a more fluid game, and this technology is usually enabled during the testing and pre-launch phases. What I often saw is the folks that discuss this enabled it only when they wanted to make sure that it's going to work in the retail environment. Otherwise, they would disable this dynamic resolution scaling because they wanted the testers to feel the performance lags that might have been occurring without adjusting the resolution to adjust for that. And then finally, we'll see especially for multiplayer games here, network quality analysis tools. Sometimes the impact that we see for performance isn't because of a client or a server problem, but because it's because of network overhead, it's because of a streaming problem or traffic on the wire. So understanding the way that network is handled is incredibly important and used during this phase. Other things that come up during this phase, we heard a lot about test case management. Now, sometimes test case management is going to really be brought up during production phase, and that's ideal. I listed it here because this is really where testing gets started. These test case management tools are all about essentially managing the test cases, the test runs, and the positive and negative responses, right? Did it pass or did it fail? These test case management tools don't necessarily automate the test runs, but rather they help you manage them and understand what percentage of your runs have been completed, where things are failing, which build things started to fail in, etc. So TestRail is a common tool that we've heard, not only in gaming, but outside of gaming. It's a nice way of defining a set of test cases, bundling them into a run, and then managing the results of that run. Wiki tools like Confluence are often used. Just recently, I've started seeing some more plugins to Jira, like a tool called X-Ray, which allows for easy integration to issue tracking tools to manage those test cases and then push passes and failures in to your issue tracking tools. During testing, and as we move kind of beyond testing into the pre-launch phase, you want to establish channels for formal gameplay testing and feedback. So Discord is a very simple and easy way to stand up a server and just engage with your community. We see folks using Reddit and different forums there as well for engaging with the community and getting play testers and understanding who can help out if you want to have a little bit more of a broad testing scenario. And then there's tons of third-party vendors out there, people that focus purely on providing game testing individuals and feedback loops for you. Often we'll see large studios have central QA teams as well, that they're shared services that can be used and leveraged by the different studios. More often now, in the last few years, automation seems to be coming to the gaming space when we look at testing and launching as well. Unity has a great simulation tool that can be used. Most often what I heard, custom scripts that were developed. Every time a new asset or a new gameplay instruction was built in, they made teams made sure that they had custom scripts and custom coverage scripts that were now covering that new asset, making sure that it got used and tested, and that the results of the test case were tracked properly. So a lot of custom coverage is what I saw around building scripts to ensure that we've got coverage of new assets and so on. Finally, once we move past testing and you move into launch, a lot of people start to think about how do I monetize? How do I make sure my users stay engaged? How do I adjust and tweak when I need? And finally, how do I run this multiplayer environment that I might have just thought about during production and now have to run it fully? So these are the kind of three sets of tools that we saw once we go to launch and have a live game that you need to operate. The first set of tools is around analytics. We see some structured tools, package tools, Delta DNA, PlayFab. These are great tools for understanding engagement with your user base. We also see people building this themselves using the Google Cloud or Microsoft App Center and storing individual metrics, events like game session start, game battle played, game level entered, this weapon used, etc. All of those types of metrics can be used and developed in custom analytics solutions provided by some of these cloud vendors. We also see people now really needing to run their live ops services. So during production, they will have decided on a multiplayer service. Here is where kind of the rubber meets the road. You really need to focus on maintaining those servers so that you have multiplayer matches if you're engaged with that, so that you have proper in-app purchasing if you need, proper leaderboards, all of those things. You can develop them yourselves, or you can use these popular platforms so that it makes it very simple to run them long term. And then finally, games, you need to make money off of these games. Sometimes it's just from a purchase up front, but oftentimes there's in-app purchases and monetization that has to occur. I've seen monetization in two basic areas. One is through advertising. So you'll see things like Unity ads or MoPub or Google and so on to provide ads in your game. And then there's in-app purchases. Unity IAP, for example, a nice platform for enabling for purchases here. So this should have taken us through kind of the 5 phases there of the game development lifecycle and the different tooling that people use, the different classes they use, and kind of why they use it. So to wrap up here, the 3 takeaways I want you leaving with: 1, there are a bunch of different dimensions that impact the tool that's right for you in your studio. It's not one-to-one. Hopefully by iterating through some of the things that we've heard from different studios and the benefits that we've seen from some of the different package tools versus custom tooling, you can start to get a sense of where you fit on the scale and which dimensions will help impact will impact the decision that your team makes. The second thing I want you to take away is that there are tons of vendors out there that do provide good competition so that you have a good set of tools to choose from. But the third thing is not every tool fits everybody, so we see custom tooling fitting in to help studios close the gaps when there's not an existing package solution out there. And Backtrace is here to help game developers provide a more crash-free and stable experience for their players. Thank you for joining us during the session. We hope that you've learned a little bit about what other studios take into consideration when they're looking at the different classes of tools to use, and that this has expanded your perspective and knowledge a little bit. Please feel free to provide feedback. We really do appreciate anything that you have to say about the tools that you use throughout the day. And join us at the Unite Now pages for more information. Learn more about Backtrace at unity.com/product/Backtrace. Thanks a lot.